Orange is a new black, blockchain is a new JavaScript, and GraphQL is a new REST. What do those three statements have in common? They're all complete fiction, obviously. So I'll talk about the future web today. And the future web will be quite different from the web that we have today, in the sense that data from different people will be stored in different places. Whereas today, all data is, of course, in a small number of centralized places. And we at UGent IMAC, we are querying the web with JavaScript because we believe this web is coming. And if data indeed is going to be spread around the web, we'll need a good query engine to deal with that. So the reason I'm here today is I'm actually very excited to show you all the things that we're doing with JavaScript, which I believe are really cutting edge. At the same time, I also want to give you a different image of what it is that we do at UGent IMAC. Because when I tell people that I'm a professor at UGent, they think I teach the whole time. Sorry to disappoint you, but let's see, a working week is 38, 40 hours. I only teach 15 hours a year. So what do I do all the rest of the time? I try to solve problems that haven't been solved before, and I solve them with a little bit of science and a lot of JavaScript. So everything we do on my team is all JavaScript based. You saw Peter's take on this. Here's going to be a totally different take, but still very related. Step one, I'll talk about querying the web, what this actually means, what kind of things that we want to enable. The second thing is going to be about the Solid project, which is a massive undertaking to redefine the relationship between people, apps, and data. And the final part, I'll switch to really hardcore JavaScript. I'll do some live coding to show off some of the things that we've been building. So if you want to see live JavaScript, the last part is what should keep you going. Let's start with querying the web. First, a little bit of background. So JSON documents, as we currently use them, a problem with them is that they only have meaning to one source. So a very typical case, you arrive at a new API, you need to write a front end, or your backend developers have made something, you need to agree on what the field names are, what the structure is, right? This works for one API, works for two APIs, might not really work for 50 APIs anymore. So if you want to query the web, the fact that these things have only local meaning is problematic. We do a slight change in that. Is what we use is JSON LD, and LD stands for linked data. Think of linked data as the alternative to big data. Big data is bring everything together. Linked data is keep everything where it is, but connect it. So what we do is we add a small thing to the JSON blob, basically, but a small thing has big consequences because now those fields suddenly get a universal meaning. You don't have to know about the details, but just a small hint is that what actually happens is that those fields, they get URLs under the hood. You don't see this. But URLs, as the U says, they're uniform, they have universal meaning on the web. So this is how we go from a local JSON LD file to data that is linked up all on the web. Have you heard about schema.org? Well, this is just all linked data on there. So it's nothing fancy that we invented. Google, Facebook, and so on are also using these things. A similar story I can tell about GraphQL. Those queries only have meaning for one source. Are there any GraphQL users here? Good, awesome. You like this, or maybe not. What does a query look like to list 50 people in GraphQL? Well, the answer is it really depends on the data model, right? Just like with JSON. This might be the right query. This might be the query. It might be users table with full name, or it might be friends and display names. There's many, many options. And the problem is that this query will only work with one server, but not with another, which is very problematic if you want to query multiple servers at the same time. So what we do is a language called Sparkle, and the fancy details don't really matter. It comes down to the fact that these things, again, have universal meaning. So this query, I can send it to multiple databases, and they all will send me an answer. That's the idea behind it. Similar principle, also URLs under the hood. So what does this look like? What is querying the web? Well, let me do it live. This is the same query where I'm going to look for give me 50 people. And when I click execute, what's going to happen is that some JavaScript in my browser is going to start making requests to an API to retrieve this. In this case, I'm going to send this query to DBpedia. DBpedia is kind of the linked data version of Wikipedia, right? So when I do this, results start flowing in, and those are 50 random people from DBpedia. Nothing special. I could have done this with regular API calls as well. However, here's a cool thing. If I put a different data source, let's say I put my own data in there, well, then I get 50 people from my website, which includes Peter there, by the way. So this is possible. What I can also do is I can take the same query and execute it on both data sources at the same time. And then I'll just get a mixture from the different sources altogether. So all of these things are possible. And that's the idea, that with one query, you can just query the entire web, basically. So this is why we use a slightly different language, because these queries have universal meaning. What's happening under the hood? Well, the query engine you just saw is something we developed at UGent IMEC. It's a Communica engine. What it does is it takes queries and it will check first with the server, what kind of API do you have? What kind of language can we speak? Based on that, it will break down the Sparkle query into requests the server supports. It will send those requests, then get the sub results and combine them all internally. So as a developer, you don't have to care how the query is executed, what APIs are there. You just use a simple query. It's written in TypeScript, it's open source, so you can check it out and you can actually use it in your own projects if you want. You can try it here, it's on GitHub. And how does it work from a user perspective? Well, basically what you do is you just import the package, start a new query engine, and then you just call the .query method, you send your query, you send a list of sources, and then you can go through to the results. So this is just a simple event listener with a stream of objects. So as simple as that, basically. Now, the really cool thing starts when we use this to query multiple sources at once. Because previously I did something interesting, like I retrieved people from 2 websites, but I could have done that as well individually. But what if you have a query you can only answer with multiple sources at the same time? And this is an example of such a query. The story goes, I'm standing in front of Harvard Library, but I'm a bit homesick and I wonder, do these guys have books written by people from Ghent? Now the thing is, Harvard Library knows what books they have, but they don't know where the authors were born. DBpedia and Wikipedia know where people were born, but doesn't know what books they wrote and what books are available in Harvard Library. So we need the combination of these 3 things to do it. Guess what? When I click execute query, we see the results flowing in. I'm not a librarian, but Cutler apparently is indeed a guy from Ghent, and this book is something they actually have in Harvard. So all of these things become possible. This is kind of the future of building web apps. Instead of having to worry about all those requests sending to APIs, what you need to do is just build a good UI and the query engine does the rest for you. So this is the way we want to start building for the web. Now, you might wonder, okay, why? Why would we start querying different sources? Are 2 or 3 APIs not enough? Will we ever have this thing? Well, this brings me to the second part, where actually we look into a couple of things that are going wrong with the web today. So let me start with all the good things about the web and the things that are going wrong, and then switch to the solid ecosystem, which is about fixing things that are wrong with the web today. The web, as we all know it, brings freedom of expression to everyone across the world. And this is commonly summarized as anyone can say anything about anything. And the good thing is we all have our own spaces. So unlike a blockchain, for instance, we don't have to agree. We can all say what we want without repercussions, almost. And the thing is, I can react to what you write, even though we're talking on different spaces, because I can link to what you write. So we don't all have to be on one website. We can be on different websites and just link. And this is how we can have a discourse without having to agree. This is very important. And the equivalent of permissionless innovation means that this is actually freedom of speech for developers. Permissionless innovation means that anyone can build anything for any reason. You don't need anyone's permission to join the web and launch a new idea. You could say, well, of course, why would I? Actually, with App Store is not the case. If you want an app in the iOS store, you have to satisfy quite a lot of conditions. On the web, that's not the case. You can just build something today, tomorrow you have an online shop. All of those things are possible because no one is watching over your shoulder. And permissionless innovation has been responsible for a couple of crazy ideas that are totally normal today. Like the fact that if I'm in the Netherlands, I can from any city just call a taxi, it will arrive right where I'm standing. This is boring, but 10 years ago, this was totally crazy. The same things with like Twitter, Amazon, eBay. The fact that I can get the package delivered on my doorstep tomorrow, 10 years ago, that wasn't so evident. So the web has been responsible for all of these things. Now, unfortunately, we have lost control of our personal data on the web. And this is not only bad for the freedom of expression, it's also bad for permissionless innovation. So things that used to be on people's personal blogs and websites are now on Facebook and Twitter. And okay, we have to admit they have a super user experience, but we lost control of our personal data. This has immense consequences for privacy. Fortunately, no one cares because everyone is still on Facebook, but also endangers the core principles of the web. Because then you start seeing things like you have to sign in with Facebook to see this content, to use this app, or even worse, you might want to use the native app. And once people are in the native app, it's very hard to get them out, to get them to use our apps, right? So for us as developers, this is a threat. Facebook is not just a threat to privacy, it's a threat to permissionless innovation. We depend on Facebook to innovate, and we don't want to. And this is often called the walled gardens of social media, right? And in order to operate, you have to move the people or you have to move the data. Simply said, if I want to share a Facebook photo with my LinkedIn colleagues, I have to move the data or I have to get people off LinkedIn into Facebook, right? And this is crazy because on the web, that didn't exist, but social media and many other sectors have created those walled gardens. And this centralization, it hurts diversity, it hurts innovation, it hurts the choice that we have online. And let's be honest, if we have a budget to build one integration, will we integrate with Facebook.com or will we integrate with some local company who also has a very privacy-friendly solution? We will choose Facebook, obviously. There's another example of how we tie our innovation to Facebook. So we as developers, we depend on those centralized platforms for data, for identity, or we have to become the next Facebook. Well, good luck with that. And the consequence for people is that they lose control of their data and they can easily switch to other apps. And that's bad for us because if people are hesitant to switch apps, how will we attract them? How can we, say, hey, we also have a nice thing? It doesn't really work in this model. So that's the good story of the web and what is threatening all of the good of the web today. Let's have a look at the solid ecosystem. Maybe this name rings a bell. Tim Berners-Lee is the man who invented the web. So kind of thanks to him that we're here, because without the web, there wouldn't be any JavaScript, would there? And what he summarizes with this one tweet, this is for everyone, is he emphasizes this permissionless innovation, this universality. The fact that anyone should be able to innovate, to build things, to save things. But, as I explained, things like Facebook are threatening our freedoms. And this is something that Tim Berners-Lee himself is very worried about. Like he sees his invention fall apart because of these things. So last month we celebrated the web's 30th birthday, but it wasn't fully positive because we're really concerned about these things. So we at UGent IMAC are working together with Tim on Solid. And Solid is Tim's vision for a better way of building apps on the web. And the main thing about Solid is choice. Solid wants to give people back their choices. Very concretely, Solid wants to give people a separate choice of the apps they want to use from where they are storing their data. That's a very simple principle with very powerful consequences. People regain control of their data and they can share it with the apps and the people they use. Sounds simple enough, but the consequences are huge. Take this view. This is something we're very familiar with today. It's a social media post. Today, a view like this would get data from one single source, right? It doesn't matter whether we're talking about social media or any other app, this is how they work. The data from an app comes from one API. With Solid, if you get the choice of storing data where you want, this means that a view like this one can have data from hundreds of different places. For instance, if this is my post, this profile picture would be stored in my personal data spot, right? This text would also be in my data pod. If you comment on my post, this comment is yours, it's stored in your data pod. And if someone likes my post, well, a piece of data as simple as a like, the like is yours, it's stored in your data pod. So all of these pieces could literally come from somewhere else. So now you start getting why the whole query API story is becoming so important. Now this has tremendous consequences on how we build apps. This is the system of today. On the left-hand side, applications are a combination of app and data. The apps, they cling on to our data, basically. And this, of course, has a side as a consequence. It's hard to share data across networks. Synchronization is also a pain. If I accept an event on LinkedIn, Doodle and Facebook won't know about it. If we invert the whole idea, if I have my personal data pod, then there's no synchronization problem because the data only has one main copy. And apps then become a sort of views, basically. I can start with one app. I can work on my pictures, continue with another app. And interestingly, the apps that I'm using can be different from the apps that you're using, but we can still communicate. That's totally impossible today. And before you say, wow, this is crazy, this is very hippie, this is how it's always been before the web. On a computer, I can open a JPEG file with the editor I want, you open it with your editor, and we still can work together. So it's that principle that we simply want to bring to the web. Now, this is great for people, for privacy. It's also great for people building apps. Because nowadays, we see competition based on data ownership. Who wins is not the best app, it's the app with the most data. This means that if we have a better idea, well, tough luck, you cannot enter the market because you don't have the data. And think about it. If any of you can name me one important innovation that Facebook has done for you in the past 10 years, let me know. It's striking, isn't it? Facebook doesn't innovate because they have your data already, right? So this means that innovation doesn't win today, and that's crazy. With Solan, what we see is that we get separate competition. We get a competition between apps and a competition between storage provider, and they're separate. This means that here, the best apps can win. And the good thing is, this is not a winner-takes-all competition. The best app for grandmas is going to be different from the best app from teenagers. So we have diversification, whereas those people today all use the same app. That's crazy. So this is very good news for app developers because it's going to be a much bigger market. The same for storage providers. There are going to be free options, paying options. People will finally have choice where they have none today. So that's a big idea behind Solan. Solan is not a platform. It's not a company. It's an ecosystem. It's a way of building things. It's a movement. It's a community. It's an ecosystem in the sense that we define the standards to make this work, just like web standards, basically. It's a movement in the sense that we want to explain to people, you can build apps differently. You don't have to harvest data first. It's a community that consists of different people, companies, and organizations who want to make this work. So what exists already? Well, we have a Solid server that acts as a data pod, and basically it's a simple web server with support for linked data and access control. That's it. It's just like a website except for personal data. It's application agnostic, so you can run any application on top of it. And just like a website, you can open it with any device, any browser, you can host it anywhere, right? So it's that flexible, basically. What's in a data pod? Well, basically, you name it. Your profile, pictures, comments, likes, any kind of data you want, you can store in there. It's your data pod. Now, apart from the apps, there's also Solid clients. They're native apps or browser apps, as you wish, that can read and write to personal data pods. So you give an app permission to do things. You can be very specific with that permission. You can get permission from friends, and then basically your app can start getting data from different places. So you get one unified experience. Again, great for app developers because you don't have to beg for data anymore. You just tap into all of the data that already exists. So it's really great for bootstrapping. What kind of apps can you imagine? Well, it's like the web. Permissionless innovation. If you can imagine it, you can build it with Solid. Calendar, social feeds, something very specific. Anything you want to build, you can build. It's the web. What's the timeline? Well, Solid started as a research project at MIT, 2014. A couple of months ago, Interrupt is one of the bigger startups in the Solid ecosystem, got started. It was also backed by Tim Berners-Lee and received quite some media attention. You might have picked it up. This January, Common Developer Toolkit and Common UX came out. And summer 2019, we'll have an MVP of the ecosystem. That's to say, Solid works already today. I'm using it. Many people are using it, but it's quite rough around the edges. It's meant for developers. It's not meant for end users yet. And then maybe, as of today, who knows, maybe I might be curious and maybe you want to have a look to see what you can do with Solid. So that was about querying the web, why I think it will be necessary to query the web. And now let's look at some hopefully hardcore JavaScript. You might think like, what is he going to surprise me with? I'm a JavaScript guru. Well, we'll see. We'll see. Because decentralized apps, they will work differently, right? So this is a single system we have today where one app, specifically one backend. This won't be the case anymore, right? Apps can go to many different backends at the same time. So we'll need a totally different way of building things. Now, linked data, what I talked about before, is crucial to solve some challenges for Solid. Like if we all store our own data, how can we connect it to other people's data? If apps want to share data, how can they do so without having to agree on everything first? And if you want to integrate data from multiple places, well, how does it even work? Those three things are addressed by linked data. JSON-LD is great for that. For instance, this is me liking Gen.js. Cool thing is, the homepage doesn't have a like button, but I liked it anyway. How is that possible? It's my data. I'm storing this like in my personal data pods, and there it is. This is an official like. So how do we connect things? Well, this is a URL for me. This is a URL for Gen.js. I just made a connection in a JSON document, and that's it. So this is how I can like something that I don't control. And guess what? Gen.js doesn't have any control over me liking it or not. How can we build apps without agreeing too much? Well, the idea is that instead of building on very specific JSON structures, we build apps that focus on patterns. So in this case, the pattern that we're looking for is I look for things that are likes, and I need actors, objects, and a publication date. And that's it. And this document might contain many other properties, but I can just ignore them. I only focus on the things that I need. So this application agnostic API thing is basically what we're seeing here. And then, of course, how can we start integrating data from multiple sources? Well, if I like Gen.js and class likes Gen.js, we can just concatenate them. You can say, well, yeah, of course, but it's not that easy with other pieces of data. Have you tried to concatenate to other JSON files or two images, let's say? Linked data, we can just concatenate it, and then we have a collection of all those things. So integration, which we'll need, of course, with many sources, is also quite easy. Now, well, where's the hardcore JS? It's coming. 2 more slides. What I want to say is that the way that we're building apps currently doesn't work. So this is what we're doing. We have our application-specific logic, and in our logic, we have HTTP requests to a backend. That doesn't work if there's multiple backends, and certainly not if those backends have different APIs. So this way of building won't work. What we need is something like this, where the application-specific logic does not do HTTP requests. There's no arrows going out. Instead, the application only uses queries for reading and writing. And it's up to a query engine to translate those in concrete requests. And this means that the servers can change, the data can move, but your application will still keep on working. Now, what does it look like? Well, we need a new developer experience, and it's going to be crucial to make Solid a success. Because front-end developers are, of course, the people who build what the apps that people actually see. And together with UX designers, they're the ones who will make Solid popular. It's not up to us backend people. The front-enders were really responsible for this. So if we enable developers, it means that we enable ourselves. And how do we do this? Well, with a couple of tricks. This is a point where I will drop the mic. If you can't hear me, I need an assistant to hold up that same mic. Good. So what we have here is something that looks quite innocent, right? It looks like we're just navigating an object in memory. Like I go to data, user, first name. When I execute, it just prints my first name because I'm logged in. That's quite trivial. However, this is actually not what's really happening behind the scenes. Let me give you an example. For instance, I can say data.user.friends.firstname, and now it will list the first name of one of my friends. Of course, this is quite boring. I have more than one friend, actually. By the way, Mohammed is totally a real person, so here's his full name. Let me loop over them. Have you heard about, you've heard about await? I'm sure you all use this by now. For await, have you used that already? That's awesome, you should check it out. It's all valid JavaScript. So let me show you that. I'm gonna do for await. I'll say const thing of. So basically, what I'm gonna do now is I'm gonna loop over the labels of all of my friends, and I'm gonna print them. See, there you have the whole list just coming up asynchronously. I could say, this is still boring. I mean, you're just querying an object in memory. Well, no, actually, I'm not. If we have a look at the network tab, which of course wasn't tracking yet, but when I refresh, it will. There we go. When I click execute, but it's in an iframe. You don't see the requests here, but they're happening in an iframe. You know what? I have the iframe open separately for cases like this. So there's a network tab again. You won't get me. Oh, shoot. You do it. Isn't life going fun? There we go. Do you see that? Right at the bottom, when I clicked execute, I was actually fetching data from the web. So what is really happening, this is not a local object. It's actually a virtual object that goes to the web to get things. This is pretty awesome because we can do all kinds of cool things now. Here I'm just getting local data basically. But what if I just go for totally random data? Because data.user, you could believe that I'm having this in memory, but actually I'm not obliged to stick to local data. I can just pick any URL from the web. For instance, what if I go to data about me? So this is just a regular property access, right? But the property is a URL on the web. So when I execute this thing, well, it just gives me my URL. That's boring. So let me do something else. Let me get, for instance, where my blog is. Well, this is the URL of my blog. That's already more interesting. Let me make it even more interesting. What if I get a list of my blog posts? Oh, cool. They're all my blog posts, basically. But there's just links. So maybe let me get the labels of those blog posts. So see, those are the latest blog posts that I've written. And just from the fact that the data is coming in slowly, you see I'm not doing a local object traversal. I'm actually querying the web at every step. Let me do a final piece of magic, because you can still say, well, I just pre-cached this. This is data from me, so the browser knew about this. Well, actually, let's do something completely different. Let's check what kind of likes we have for the Gent.js homepage. Who is liking this? Well, obviously no one, because there's not a like button, right? So when I say, give me the data about javascript.gent, and I'm looking for the likes, we get nothing. I can say, see, I knew you were querying in memory. Well, let's do something really, spectacular then. Let me copy this. Let me just create a like, because querying is not just about reading, it's also about writing. So what if I just say, actually, give me data about JavaScript Ghent, but I'm going to create a like. Move that a bit. I'm going to like it. Click execute. It gives a result back. Now, what is that result that we get back? It is a like. I just created a like of JavaScript Ghent, and this like is stored in my personal data pod. And you know what's going to happen if I click execute again? It's going to like it twice. You can even like it 3 times. Can you do that with Facebook? No, you can't. So see, these are cool things that I can do because I'm in control of the data. And talking about Facebook, you know what I even can do? I can even dislike something. So let's dislike Facebook and query for dislikes. There we go. Oh, I did it twice already, apparently. This is me disliking Facebook. There's a piece of data out there that proves that, well, I don't like Facebook. So all of these things I can do. Which leaves us only with one question. How does this piece of magic work? Because it looks like a local object, but actually I'm querying the web. Any guesses how this works? Told you it's going to be hardcore JavaScript, right? There's a small trick. So this language is called LDFlex. We've developed that again at university. It's a domain-specific language. So this means that every LDFlex expression is valid JavaScript. Right? Now the trick is that it feels like a local object, as you've seen. It uses Proxy. Have you heard about JavaScript Proxy? Proxy is magic. And because of Proxy, if we put a weight in front of it, it behaves like a web query. So this looks like just path access. The moment you put a weight in front of it, it starts fetching things from the web. How does that work? Well, and actually, by the way, not just from my data space, but from everyone's data spaces. How does the proxy thing work? Well, basically, if you want it to behave like an infinite path, it will behave like an infinite path. So a proxy gives you the ability to make any object behave in any way. So how did the trick with await and so on work? Well, actually, if I put await in front of it, then the object behaves like a promise. And all I have to do is just add a virtual then function, and suddenly I can go to the web. So that's what's happening. And now the for await off trick, how did that one work? Well, same thing. To work with for await, an object has to be an async iterable. So thanks to proxy, I can make this object behave like an async iterable. And by just making objects behave the way we want, we can convert a simple path into a query just at our fingertips. And this is the kind of magic we believe we need. This can be combined with lots of existing tooling, like React, for instance. So we're building integrations with React. So building apps with Solid is really easy. You can just say, well, welcome, user.first name, give me the user's profile image, give me a link to their inbox, give me a list of their friends. All of these things are possible with simple React, but it's enabled by LDFlex because these very simple expressions actually open up a whole array of magic they can do thanks to JavaScript. Was that hardcore JavaScript? Kind of. I explained that we're querying the map. I also explained why this is going to be more and more important in the future. I showed you off some hardcore JavaScript with Proxy. You should check it out. It's awesome. You can actually try this on the live web. So I have something that's called the LDFlex Playground, where you can try any kind of expression. It will just evaluate it for you in the browser. Final words. Well, takeaway here is that on the future web, people will be in control of their data, which means that it will be stored everywhere on the web instead of just in a couple of places, as is the case today. So we'll need a new developer experience, and we're already building that. And in that experience, queries will play a major role. So if you want to try that out, see you on solid.interrupt.com, where you can already get started with all of these things. Final word. Again, university, we're looking to collaborate on these things. Like, we are not just academics building stuff for fun. We actually want to help Flemish, Belgian, European industry to tap into the new ecosystem that's going to form on the web. So if you're interested in this new privacy preserving way of building apps, this new way of doing permissionless innovation, come talk to us, because there's many exciting ways in which we can work together. That's it.